So now, while we're doing all this, I want to actually show you some secret patterns here to try to put this together here. Any point on a position time graph just tells you your x, where you are, your position here. But here's what's kind of cool. If you take the slope of any point on a position time graph, how do you find the slope of a line? You guys remember? It's basic math. It's just rise over run. It's how steep this line is, right? Notice if we want to find the slope, it's my rise over run, right? The rise is my change in x on the graph here. The run is this time over here. Wait a second. Delta x over time. Is that deja vu? Hey, that's deja vu. That's what? Velocity. So the slope of a position time graph tells you velocity. So how's that helpful? Here's something that's really helpful. It's easy to figure out the speed of like a car going at a steady speed. So if you look at this little clip, if we have a car just driving in a straight line, the slope of this line tells me its speed. It's just distance over time, right? But what's more complicated is, what if we have a car that's speeding up? So let me do this one. This is a car on a ramp here. And here I have my good friend, Mr. McLeod, Earth Science teacher. He's a guinea pig. One day I just grabbed him after school. It was in the winter. You can tell it's cold. He's got a big coat on. I'm like, Mr. McLeod, can you take this toy car and just let it go down the ramp? And he's like, so anyway, when a car rolls down a ramp, does it move at a steady speed or does it accelerate? When you go skiing or snowboarding in Colorado where there's real mountains and you can go down a real hill, you go at a steady speed or do you accelerate? You will what? Accelerate. And see how this curve, you see that? So suppose I want to find the speed at exactly this point in time, whatever, 1.3 seconds, yeah? Why can't I just do 0.7 meters over 1.3 seconds? Why doesn't that work? Why can't I just say speed equals distance over time for something that's accelerating? Does your speed stay the same or does it always change when you accelerate? It always changes, right? So that's only the average speed. So to get the speed at exactly that point, I actually have to take the slope at that point. That's my instantaneous change in speed. So how do you take the slope of a curve here? Anyone know? You can draw in a line that only touches a curve at one point. What's that called? It's called the tangent line. And the slope of this tangent line tells me the speed at exactly that point. Like you're surfing or something like that, it tells me how steep that curve is there. That's kind of cool, right? Because notice, it'll give me the change in meters, my change in my rise over the change in time, the run there. So for your project, you're going to get to use this tracker tool. What's really cool is you can actually have the computer then help you find the slope at any point in time. So notice here the slope is very shallow. It's only 3.16 times 10 to the negative first, 0.316 meters per second. And then here, as the car rolls down the hill, the slope gets steeper. It's speeding up to 0.8 meters per second. At the very end, it already sped up to, oh, actually it's off the graph, so I can't get the slope there. So the slope tells you the change in x with respect to time. The area under this graph is not helpful. It's just junk. Junk. No information, because it's meters times seconds. So that's not a meaningful quantity there. The area would just be meters per times seconds. Is not helpful. Let's look next at the velocity versus time graph here. And I'll zoom in here and make it a little bit easier to see. Any point on the graph just tells you the velocity. That's the whole point of a velocity time graph. How about the slope? How would you take the slope of this straight line here, right? Again, it's rise over run. Notice what is the rise right here? It's a measure of your what? Your change in your velocity, right? And then how about the run units down here? It's your change in time, right? So what's change in velocity over time? Is that deja vu? Hey, wait a second. It is. It is what? Acceleration, right? So what's cool is if you take the slope of a velocity time graph, you'll get your acceleration. You see that? Finally, if you take the area under a velocity time graph, let's take the area underneath here. The area, how do you find the area of a rectangle? Area of a rectangle, it's just length times width. Okay, so the length here is in meters per second. The width is in seconds. Hey, wait a second, that's just meters. You see that? So a little trick is your meters per second is your velocity, how fast you were going, times your time. That's your displacement. So if you take the area under a velocity time graph, you get your change in position. How's this useful? In real life, your car will drive at different speeds. If a GPS is tracking your velocity at any point in time, if you take the area under that graph, you can figure out how far you actually ended up going. Anyone taking pre-calc or calculus? You might be having subconscious nightmares, because what we're really doing is we're doing derivatives. That's what slopes are. And the area under a graph, that's the integral. So when we do a little packet with numbers, you can actually end up doing calculus. You won't even realize it. It's actually pretty easy once you see it. Finally, let's just wrap it up before you guys get too lost here. A lot of times you just get a big picture, then the details will help click in once you get an overview. Any point on the graph tells you how much you were accelerating. That's the whole point of an acceleration versus time graph. Acceleration. Any point gives you your acceleration in meters per second squared. Would be meters per second squared per second. That's junk, because that doesn't make any sense. That doesn't tell you anything. But the area under this graph, this is actually kind of helpful. If you look at the units, it's meters per second squared times seconds. That's just going to be meters per second. Meters per second squared is acceleration times time. Hey, that's your change in velocity. It'll tell you your velocity. So how is this helpful? If you're a race car driver and you had a graph of how much you're stepping on your gas pedal, it would help you then figure out how much you change your velocity for that part of the race.